Hello students, let's learn some college algebra. So 7.3, it's multiplying and simplifying radical expressions. So there are three formulas that we are going to use in this lesson. So it's not a long one. That means you have to solve a million problems after you watch this video. So the very first formula that you have to memorize, it's n root of a times n root of b. As you can notice, the same index equals n root of a times b. So basically, if the index is the same number, you can just multiply the radicands. Remember, we talked about vocabulary. N root of a over n root of b is, well, can you guess this one? Deep n root of a over b. So if the index is the same, then you can just divide the radicands. And the last one, n root of a to the n, as you can see, the index and the exponent is the same, equals just a if a is positive. Well, if it's not, then you have to be very careful with the index being even or odd and introducing absolute value and so on. But you don't have to worry about that, because most of our problems are have the radicands positive. They usually say assume the variable is positive. So examples. Use product rule. Use quotient rule and simplify the problems. So the very first one is square root of 3 times square root of 5. Well, which one of the three formulas that we went over at the beginning you're going to use? Well, if you take a good look, you're going to see that you're going to use the first one. That's right. So it's square root of 3 times 5, which is square root of 15. Well, not big deal. We cannot simplify that. No perfect square or anything. The next one. Cube root of 5 times cube root of 4. Well, again, the same index, so it's going to be a cube root of 5 times 4. So it's cube root of 20, which will leave it like that. 3. Square root of 5x times square root of 11y, where assume x and y are positive numbers. Why? Well, because you want positive under an even root. Well, square root of 5x times 11y, which is square root of 55xy, and that's pretty much it. Another one, square root of 2x over 3, and as you see it's deep enough to cover the 3 as well, so the radicand is 2x over 3, times square root of 3 over 2. So this is square root, right, even though we don't write them. So then we can write square root and then multiply the two fractions together. We learn how to multiply, so it's a cross, or you can just divide and you get square root of x, which is, leave it like that. And we assumed x and y are positive from the beginning, so then we have no problem having just square root of x under the, just x under the root. Another one, simplify, or multiply. This one is still multiply. Square root of x minus 6 times square root of x plus 6. Well, square root of a quantity times square root of another one, right? We can just write a long square root and say x minus 6, x plus 6. And this means square root of, if you remember, a minus b times a plus b. We did that in math many times. It's a squared minus b squared. If you don't remember the formula, just FOIL it. So you get x squared minus 36. And you will be surprised, but this is it. We cannot write x minus 6. Do not write that. That would be very wrong. Why? Because square root of a minus b is not square root of a minus square root of b. So don't make that mistake. That's the final answer. The one that I highlighted, that I put in a box, that's the final answer. Do not simplify more. Well, if the answer was x minus 6 squared like that, it would be a totally different situation. That would equal x minus 6. Okay, a few more problems. Square root of 50. What if we have to simplify that? Well, if you think about it, square root of 50 can be written, well, 50 can be written as 25 times 2. Well, 50 can be written 5 times 10, and it can be written, 1 times 50. But why we chose 25 times 2? Because 25, it's a perfect square. Why I want perfect square? Because of the square root, right? It's a square root. So, based on the first formula, but written in solved from right to left, we separate into square root of 25 and square root of 2. Well, square root of 25 is 5 and square root of 2. This is simplified. 7. Square root of 75x. Well, again, we try to write as many perfect squares as we can. Well, 75, if you do factor 3, you get 5 and 15. 15 is 5 and 3. So basically, square root of 75 can be written 5 to the second times 3, correct? 5 times 5 is 5 to the second, times x. And based on the first formula, we can write square root of 5 squared times square root of 3 times square root of x. We can just distribute the root. Well, square root of 5 to the second, this is a 2 here and this is a 2. We saw in the third formula, right? The third formula, if they are identical, right, we just get a. So in our case, we just get, that's right, 5. And then square root of 3x, we can put them together because they are not perfect squares. And we simplify this one. 8. Square root of x to the 5th. Again, we assume x is positive. And you're going to see that in my MATLAB homeworks that they assume that. Well, if you think about it, square root of x to the 5th, I can write it x to the second times x to the second times x. Why I chose that? Because if we distribute the root or separate it like that, we saw the third formula says if these are equal, we just get x. Then from here we get also x. And this one cannot be simplified, so we end up with x squared square root of x. Another nice way to do it is if we have square root, we would want to write this 5 using multiples of 2. So I can actually write x to the 5th as x to the 4th plus 1, right? 4 is a multiple of 2. So we get square root of x to the 4th times x to the 1st. Now we separate into square root of x to the 4th times square root of x. Well, this one is 2, so based on rational exponents is x to 4 over 2, which is just x to the second and then square root of x. And this would be the same answer as before. 9. Cube root of y to 11. Well, as in the previous problem we wanted to write multiples of 2, this time I want to write 11, right? This 11, multiples of 3. That's right. So we write cube root of y to the 9 plus 2. True? Yes. So cube root of y to the 9th times y to the 2nd. We separate into cube root of y to the 9 times cube root times y to the 2nd. So cube root of y to the 9, y to 9 over 3. That's y to the 3rd. So it's y to the 3rd and then cube root of y to the 2nd. That stays the same. So again, why did I write 11 as 9 plus 2? Why didn't I write 11 as 10 plus 1? Why didn't I write 11 as 4 plus 7? Well, because I wanted to find the highest multiple of 3 that can fit into 11 to simplify it. One more problem. 4th root of 96 x to 11. So, the question is, what number raised to the 4th is 96? Or do I have a perfect 4th power there? So 96 is 2 times 48. 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. and 6 is 2 times 3. So basically, I can write this problem as 4th root of 2 to what power? 1, 2, 3, 4, 5 times 3 times x to 11. I can distribute it into 4th root of 2 to the 5th times 4th root of 3 times 4th root of x to 11. Now, this 5 from here, I want to write it using multiples of 4. So 5 can be written 4 plus 1. This one I can do anything to it. And the 11 from here has to be written as multiples of 4. So basically I'm going to write 11 as 8 plus 3. So we're going to get 4th root of 2 to the 4th times 2 times 4th root of 3 times 4th root of x to the 8 times x to the 3rd. So 4th root of 2 to the 4th times 4th root of 2 times 4th root of 3 times 4th root of x to the 8 times 4th root of x to the 3rd. So I just separated. So now what is 4th root of 2 to the 4th? Well, since the exponent and the index are the same, we just get 2. So I did the yellow one. The next one is 4th root of x to the 8. That means x to the 8 divided by 4, so 2. And that's pretty much it. Now let's do the blue ones. Well, the blue ones cannot be simplified anymore because there is no power more than 4 inside. So then I'm just going to copy them together as 6x to the 3rd, and that's it, simplest form. I hope this helped. Please ask questions, write in the discussion forum, ask their questions, discuss among yourselves. It's good to practice and to have conversations. Until next time, stay healthy. Bye.